expert committee decided that there has to be a topic which is little change from the regular. So they say, let's discuss about the topic, which is lacuna. And then they find me, ki boss, create more lacunas. So here we are. Look, the idea is the continuous improvement is part of process. We discuss all in management. In steel construction, the continuous improvement is possible while finding the fault in ourselves. If you go to south and find Konark temple, maybe 100 and 1000 years back they had used the steel in their construction. And as I say, in the human history, steel was one of the very important innovation because before that we did not know how to handle the tension. So most of old Indian structure from Madurai temple to Tanjavur, everything has an arch. That was a way to handle the bending moment those days. From there, steel development has gone from the Empire State Building where we have used the pure SS columns and all. And now we are in India where 15 years back when we discussed, there was no concept of a structural steel company. There was hardly any. Material was not available. From today where we have a significant improvement on that. We started this SSMB seminar from 15-member rooms to now 100, 200-member rooms. So I'm just giving on a little historical. So today we want to talk about the lacunas or shortcomings and what are the areas which need to improve on that. So my esteemed panelists is there from a different background, luckily. And we will take you to the journey of our learnings. So my first question, I'll come to Mr. Mohan. Where you find today, if we see, there's a lot of misconceptions about the steel, and there is a lot of difference in quality in the tier 2 contractor to tier 1 contractor. There's a huge difference in quality. Not normal, huge difference in quality, and that is probably making a lot of bad assumption about it. So can you help understand what is your views and take on that?
Quality of the product or construction? Yeah, definitely it depends upon the inputs. Whatever, finally, there is different criteria, tier 1, tier 2, tier 3, in all segments. It is not only in fabricated segments. The inputs what you use, basically when we talk about fabrication, it's from the design, what type of designs we get in, whether we are really trying to use the complete codal provisions, or for getting an order, we try to optimize and try to tweak the codes to reduce the weights and then win an order. That's one way of, when they do not have that type of, if at all a very good designer tweaks it, it is still okay, but they don't really tweak on the codal provisions. But companies who cannot really afford such a very good design setup, they normally try to tweak the codes to get the lower weights and then try to supply the building. That is one. Second, when they are doing the fabrication. Fabrication in steel is basically 3-plated construction. You take a plate, cut into different sections, and then you weld it. And if at all you are using, let us say, to save cost, a lower quality welding wire, the quality of the weld will be not that great. Whereas the type of quality, like people use submerged arc welding, like what we do, some people are using a normal welding. The wire, like Kirby, we try to import even welding wires even today, only to ensure consistency of quality. So as I always tell, the strength of the chain is as good as one of the weakest link. And if the weld quality is bad, that is how it comes down. So if you really see the quality of paints they use, they are different. Like, normally they go by per liter weight, but we look at the volumes of solids in a paint. So the cost of the paint may look high, but the finish and the longevity is very good. So there are a lot of things. And then when it comes to the construction practices, the construction practices are completely different. The safety practices, like when you give a priority for safety, definitely it costs. But is that cost such that which you can avoid? In the present situation, no. Maybe few decades back it was acceptable, but right now I don't think. So these are some things which would build up, but built up to increase the price. I always say in many of these sessions, there is a lot of difference between price and cost. Price might be little higher, but the overall cost will be lower. That's how I always say. Because let us say one accident in the site, the cost is high. Or the project get delayed by a month or two. The project, the cost is high. The quality, or in case you have some quality issues after 1-2 years, it's cost. So we have to look at the overall cost, not only one small price. Unfortunately, a lot of people play with the price. We need to look at the big picture. This is what I feel.
Yeah, thank you. Amit, one question to you, a little straight. You design the building. So what fear you have? What kind of things may go wrong at site? So you have to keep provision for that. Like when you design, you're thinking, this area will be based on a contractor. This area I have to be a little more careful. And on the end of the day, design comes as a your baby. So what you think?
So that's endless. Let me be very honest. It's endless. When I am designing, I don't know who will fabricate it. I don't know who is going to erect it, under what condition this will be constructed, and even after it is constructed, I have probably not seen 90% of it, how it has happened. And at end of the day, I am writing a guarantee that this will stand forever. That's a way of it. So every designer needs to visualize those conditions, that there can be a problem at site because of this. That is designer's duty, that's principle. That's what he was also referring to. You need to have a good designer who will understand these requirements. We are really hitting in air. I mean, many times we are only conceptualizing the project. No structural engineer is going and supervising construction full time at site. So we have to visualize those erection conditions. During erection, you will erect this, you will not erect this. What will happen to structure? During erection, you have not connected the bolt. It's just hanging in air, what can happen? Or you give those instructions in drawing, in design we write down. Structural GAs we write that when you are fabricating this, when you are erecting this, please follow this. If you don't follow it, I don't stand guarantee of the structure. It is designed with certain assumptions. Please adhere to those assumptions. We'll make sure that it is correct.
You have to mitigate somewhere. You have to mitigate that risk. Probably it end up on a over designing and the what effect on
exactly. Otherwise, I'll have to over design. If other side is not going to follow my instructions, I will have to over design to ensure safety of building.
In some of the complex structure, I find out many times there is a pre-construction contractor discussion, so that helps a lot.
Yes.
Mr. Das, sir, you have seen the two different world. One is organized world and at Singapore, and the one is the developing world. And you mentioned one of the important things is still need a discipline. So what you are seeing the difference in the practices in India and the practices in Singapore in terms of steel fabrication, erection? What are the differences you find and where there is a chance of improvement?
Okay, I mean, I've been in Singapore since 1975. Okay, and I can still remember the very first building that I was involved in. I was a consultant at that time, and it was a building in Sabah, which was almost in the middle of nowhere. And it is a tall tower where you only have a central core, and the building is hung from the outside at 2 levels. It's hanging, there are no external columns. Now, this building was fabricated in Singapore and sent to Sabah for erection. But frankly, it was fabricated in a jungle in Singapore. Okay, this was 50 years ago. Now, during this entire period of 50 years, it has evolved from that position into some excellent fabricators who can match the standard in any part of the world. And recently we have done a project in Singapore which is the largest covered dome structure in the world, which is the National Stadium of Singapore, which has a base diameter of 310 meters. Okay, so you can just imagine the growth. So in a similar manner, I would say that India is just starting to grow in this subject of steel. I mean, they have almost not used steel for a long period of time, and I think about 20 years ago, they would have started the use of steel. And today, and in a much shorter time from what I can see, they have evolved into projects which are very, very complicated. Now, I think the requirement here is that for the developer and the main contractors to understand that steel requires a lot of discipline when you go into these mega projects. Because if you don't have the drawings ready and you try to rush the process, then you can't really rectify it easily. Steel is not like concrete where you can add a reinforcement bar on site and settle a problem that you suddenly find yourself in. These are things that are fabricated and brought to site and erected. So you really need the discipline of having the design done early and starting the fabrication as early as possible in order to get the project done within a reasonable time scale. And I think that is part of the lacuna in the industry today, that people are still learning and trying to understand that this change from doing 30-meter, 100-meter tall buildings or large span buildings to buildings that are now spanning 50, 60 meters for roof structures especially, right? And it will take them some time to understand that there is a reasonable time required. I mean, when you ask people to do something within 3 months, you have to deliver steel to site on a project like this. Honestly, it's not easy to do. It's in fact very difficult. And this is the growth that India is going through. And like all countries, I am absolutely certain that they will succeed in this understanding also in India.
We are nation in hurry. We are building everything very fast. One point to audience, we will like to make little interactive. As I say, little interactive, so not verbal. If you have any question or anything which you want us to discuss, please send in a slip. We'll see if we can accommodate. The question to Amit in between, and then I'll come to PV Mohan. Earlier when we were doing steel building and we find the designer don't think steel. This is like a language. So you first think in your mother tongue and then you convert in English. This is very common there. So designer were thinking concrete and then making the steel. But today I think that phase has changed. People have started thinking steel. They know there is a shop drawing required. They know the process on that. Where you find? Because I still think that skilled manpower in the design and then the later stage is still limited. The knowledge is still limited available. Because of very popular alternative, which is a concrete, you have a limited people in the industry who take care of structural steel, fabrication, erection, and design. How you view on that? What's your take on that?
See, number one, yes, many engineering colleges still do not have elaborate courses on steel design. Reason maybe because not even good professors are available to teach them. Okay, maybe, I'm not too sure whether that is true, but yeah, that can be one reason. After that, RCC is very easy option. Okay, you start getting small projects also, you start earning fast, quicker options, whereas if you have to do a large industrial project, people will need about 5-7 years experience. Day one, nobody will trust you with those bigger projects. So maybe because of that, because of lack of patience, people start choosing RCC design as their career choice. Later on, once they have 5-7 years, 10 years experience, as soon as they get opportunity to work in steel, they would like to do that. Today you ask 10 civil engineers, I give you choice whether you want steel or RCC. They will say, I want steel, but I should get that option. Somebody should let me design structures. right? So the onus is on both sides. One is we have to train them in engineering colleges. They should be taught properly, number one. Number two, when they come out, if they want to choose steel design as option, somewhere they should get opportunity to do that. Okay. Now, having said this third category, there are many engineers who have been practicing in industry, who have worked for 10, 15 years or 20 years, but all 20 years they have designed RCC. Now, those people are not going to be recruited in steel, or they cannot go back to engineering college also. They will have to find out way themselves. They will have to do career upgradation, their capability upgradations and all, continuing education programs. They have to upgrade themselves and get into steel. You need to have enthusiasm. You have to believe in yourself that I can do it and let me do it. Right? So there are all three category of people around, and if we start addressing one by one, I think we will have a good pool of structural engineers who are good in steel design.
This is one area which is, we say, the lack of highly skilled manpower, which is design.
Yes.
One, in a state, you are working on a organized sector of steel. I'll not go in PV, but I'm seeing you are one of the first one to move in a organized sector of steel, and you have get some minimum standard, and then you had upgraded on that, correct? But you had seen all those other people are doing. So what do you think, which are the area where the lacunas are in the fabrication and erection design we spoke? So after design, what? I find sometimes that there is a lack of people skill for shop drawings. That was one area very few good people. And then of course fabrication, low quality of welding rods, all no drilling, no instrument and all. What are the area you find the general lacunas were there, and whatever the probable way to mitigate?
See, if you really see on the, let us talk about fabrication initially. Fabrication, you see, whatever we are building right now in steel is not something new. This was there for few decades, even before, pre-engineered building came in. It was being done at sites. There was site fabrication. And at a site fabrication, it is being done by normal contractors with no formal education, but with experience. They have learned certain things and then they start building. Today we do that, we see that even in civil. Houses are built by some small contractors who are not really educated, but with their experience over a period of time, they understand what to be used. So steel industry as such has graduated, but still quite a lot. Like what, to the previous question, I would say, the reason why people are not really interested in steel is that today in the total construction industry, steel is still in single digit compared to the overall market. Maybe 4-5% compared to 100%. Why they should really
not even 4-5%.
I'm just trying to be little
reasonably good.
Because in this forum, I don't want it to be putting so low. So why they should be interested to really get into steel? Get into something which is structural steel or anything. First of all, nowadays we find that civil engineers itself are a rare commodity. No engineering college. If you really, most of the engineering colleges are closing down their civil departments because people only want to go for IT. So now what's happening? Coming back to our question, in manufacturing, people are really, when you are coming to a tier 2, tier 3, what does it mean? Fabrication. Fabrication is, earlier also people were doing at site. It was at a lower volume. Now you have to churn out bigger volumes at a repeatable pace at a faster time. So for that, what you need? You need guys who are big enough, they put up proper machines where the consistency of quality is maintained, accuracies are maintained. But the same fabrication can be done by a normal welder, and the skill set of that welder will determine the quality of your product. So you have to differentiate whether you need to have a consistent quality or or you are depending on that skill set of that guys. So if you really look at the small, when we are seeing a lot of, I would say, small players who are coming in, while they have brought in some welding machines which are automated, and they are trying to really pick up on the quality because they are forced to do that. But still, when we really see the quality which comes out into the market is very, very inferior. I would say inferior on the look, or even when you normally, unfortunately, the welding or the steel, that quality of it will be only known by destructive analysis. You cannot keep on breaking everything.
Look, I have a different argument. If there is a small contractor or a small builder and he is making a small building, and he comes to organized player, and he go to unorganized player, price difference is 30%, and he says, no, no, it will not fall. That, look, it's an attitude, it will not fall. So probably, I feel that probably there are a lot of more innovation, or a lot more.
No, if at all that 30%, if at all he says he's not fallen, if at all he can insure it, and he can really,
No, no,
if future gauge it and say
I'm
that not
saying
fall, it is fine.
It may still fall, but again, his mind is, I have said 30%, it may not fall. That's the.
That is what I was saying. There is a difference between price and cost.
It may not fall is a great assumption.
We wish, that's the wish.
Sir, for you, the question is the developed world where you have a lot of steel construction, which is like a UK or a US, compared to India, which is developing. One of the things we always find debate, sections are not available versus my manufacturing friends, everything is available. But when I talk to the vendors, he said, no, no, nothing is available, or available with the time lag. That put added pressure on the timeline, and of course, when the timeline is a pressure, everything suffer. So what's your thought? What's your experience in terms of we discuss availability of manpower. Now, what is availability of material? How does it affect my the overall process?
I think on the availability of material, for example, what we have noticed is that there appears to be no one who can more or less confirm and reliably deliver large quantities of certain section sizes for a project. I mean, what I've noticed is that there are quite a few developers who, even though the price of the plate is the same as the price of a section, they prefer to take a plate and pay the additional price of building it up into a section because it is more reliably available, the plate. If you rely on the section coming on time, then you have to be in a position to order that well in advance to ensure that. And you must have sufficient volume to make it viable for the steel mill to produce it for you only. So there is a definite issue related to material delivery. Now, in a country like Singapore, we don't produce anything. We don't produce sections, we don't produce plates. So we buy from anywhere in the world. And if you buy from places like Japan or Korea or China, you're generally quite reliable in the delivery period. You know for a fact that within 4 months you will get precisely what you have asked for. But this situation is not necessarily true here. In fact, even if the section is available, you may not get the necessary length that you have asked for. It may be slightly longer. These problems exist in terms of material availability.
Mohan, what's your take? You are probably largest consumer of those materials.
See, what you say is right. If at all we are talking about some, structurals like maybe UCs or some narrow parallel beams and all. But in India, we normally are not really using that much because basically in India we can produce more of, I-beams much faster, built-up sections basically. And there are two reasons why we do it. One is that there is no time. Here, most of the customers, Like if at all we say they would like to have buildings within 4 months, why not 3 months, 5 months and all? Whereas the lead time of this, suppose I procure this material, that itself is 2-3 months. So once they give an order, or sometimes it is LOA, the day starts. So there is no time. So that is one reason. Second important aspect is that in India, the price is a very, very critical thing. So you need to optimize the weight. So if at all we take a structural element, let us say any type of beams or channels, the kg per meter is much higher because that is a standard thing where you have this similar standard web and flanges. Whereas in a built-up, you can play with that. You can definitely optimize the steel much better. So that is the one of the reason why in India we are going for that. And second important aspect is that maybe I would say, necessity is mother of invention. These were not available earlier. So this has forced us to get into it. And maybe this is working out better now in that aspect, yeah.
Look, in India, steel is branded as a costlier construction method. And probably true also. But it's branded as a costlier construction method. Without realizing, if you go to high rise or you go for long span, or you go for like railways has gone for a concrete and all those things, but if you go for a very large span and all those things, steel may be probably more economical than the alternate method. So this branding, how do you see? Means, Amit, you may be facing any client you face, you say steel, is a costly. That's the first reaction of any developer or client until, specifically needed. So
yes. Yeah, what you said is true. By default, steel is expensive, concrete is cheaper. But when you go into details of that, there are specific places where concrete really will be cheaper, and there are specific places where steel will be way cheaper than concrete. For example, in many of the buildings, I have said, whatever amount of reinforcement you put, I will complete your building in steel within that much steel tonnage. Concrete is free. Shuttering, etc., time constraint, I'm not factoring any of that. Only reinforcement and complete structural steel here. Structural steel will be cheaper. You need to understand where concrete is required or where concrete is going to be useful and where steel is good. There are different property. Steel is excellent in tensile forces. We all know that. So use steel there. Don't try to use concrete there. Similarly, concrete is too good in compressive forces. Use concrete in compressive forces. If you put normal fundamental knowledge also, you will conclude that steel is way cheaper. You talk about any industrial building for that matter, you do it in RCC and do it in steel, steel will be at least 30 to 40% cheaper than RCC.
But that knowledge is not available, it's not percolating.
It's not percolating, but yeah, it's never too late. It will start percolating. We have seen in earlier presentation the consumption of steel in India was this. It has increased by 1.5 times and all. It is increasing and it will increase. Steel is definitely much stronger and much more reliable material than concrete. That stands.
You are not considering the cost of water and sand now.
That's still not factored in. Yes, of course. That is still not factored.
Let's not put down the concrete. In spite of our in spite of our seminar here, in spite of our seminar here, this is the debate. More than 90% construction is in concrete. Concrete is one of the most preferred method. They did lot better innovation than steel. They got the higher grade of concrete. They got better shuttering technology. So what happened is steel, the advantage which was, this question I'll ask you all three. Look, steel advantage in a building was, okay, I'll do in 7 days. But concrete started reaching 7 days. So what happened? You are losing the advantage, and that is basically the biggest lacuna or your advantage which you are missing to your competitor.
No, I'm not factoring time at all. I'm sorry, I'm not factoring time at all. I said very specifically, steel is good in certain cases, concrete is good in certain cases, use it judiciously. Nobody is trying to replace concrete. And nobody can, really speaking. But wherever steel has a strength, steel has a strength. I can tell you, if you talk about life of a structure, specifically life of a structure, show me one RCC building which is standing for 100 years. And for steel building, you yourself can produce 100 examples.
I can give you the stone building standing from 100 years, Tanjavur, the
RCC.
Vradishwara temple. So,
No, that's not RCC, that's stone.
I'm saying,
Stone will stand for more than 1,000 years even. Stone is okay, but not RCC.
so point well taken, sir. Is the steel losing advantage? This is the biggest lacuna in terms of overall process. Is steel losing its advantage to the alternate material like concrete?
I think what happens with steel is that for a start, whether steel is a preferred way to do things will depend also on whether you are in a city where land is expensive. I mean, when you do a building, there is a land cost. So if you can build a steel building much faster than a concrete building, then obviously there is something to be said there. But there is also this additional advantage that steel brings to buildings is that it reduces the weight of the building. Now, the moment you do a very tall building, just to give you an example, we did a project where it was a 200-meter tall tower, and they had 5 basements. So the contractor was going to start with basement 1 and go down at the same time as going up. You can do this by putting king posts and going up and down at the same time. Now, in the case of this project, the engineer's requirement was that if you went down and you retained they had a concrete solution for this building. It's an office tower. You could only go up 5 floors of concrete and you had to reach the foundation. Okay? So
it's a more of a case specific, as Amit says, there are few areas where you really do the steel benefited and like large span and all those things.
The benefit here is that you could, in concrete, the weight was so much that you could only build 5 floors of concrete. But we gave a steel alternative where you could do 15 floors.
Yeah.
So that allowed the contractor more time to get to the basement, and coincidentally, he just completed the foundation when we reached the 15th floor. So you have these very different scenarios where sometimes steel becomes almost a natural choice and concrete is natural choice, and there are situations where steel is the only choice.
Let me take audience question first. Only 2, I am looking more. No, please send the slip. No verbal. It will not be able to, for me to manage it. I'm sorry. That is only end of it. One of the question has come that we are competing with the China as a tower, speed of construction, high building in short period. So the question I think is more of what are the methodology of design or erection methodology to achieve that time frame that China is building the very fast. So do we need to compete with the China because we are building for our consumption? I don't know. That's the first question. But what is the methodology we have achieved? That's a question.
No, we are also doing it equally fast. I don't think we don't have those capabilities or we don't have those technologies. We have all those technologies, we have capabilities. We are doing it also. Yes, this may not be known to everybody, may not be easily available to everybody, but there are experienced people available, design teams and all. Kirby, I'm sure you must be doing at least 5,000 ton in a month or so.
I think we missed. No, I think we missed one presentation on DRDO where they have done the one full building in a very short span. So if that would have come on a presentation, we would have got the better idea about it.
So we have a capability. We are doing it, and yes, innovation must be done. We should do more and more of it so that we still reduce the time and we can do many more building, do many more infrastructure constructions and all, and we can also develop faster. So yes, innovation has no limit. We should be working towards that. I appreciate.
But don't you see the steel? There is a less innovation than the other because in every steel day I expect few more innovation to come. So we have to talk to manufacturer on that. Okay, you want to tell something more?
On the China factor, I definitely feel uh, they have adopted this much better, and they are definitely faster compared to India. I think we need to really catch up. There are certain technologies or techniques. Of course, when I say that, they basically, their way of thinking, and India, maybe that's my perception, they go more of modular, and they're repeatable things, because anything which we talk about bespoke, or we try to take place and try to accommodate and try to start from the design stage, that definitely takes time. But they definitely are modular is one. Of course, even on their construction technologies, they are at the sites and all, I feel better, because they basically do the design to see that the erection methodologies are faster, and they go more of standardization. So that's something where we are still to catch up. And maybe that's because they have started much earlier, and they have improved. That's what is my thought.
They have matured probably. They have seen those standardization processes and all, and we are in process of seeing it. So
And they have a money.
yeah, but they earn money out of that only. By doing that, they earned it. We have started earning it. Maybe a few years down the line, we will also have that.
So next question is from Mr. Sunil. Actually, it's not on the main topic, but still, what is the best way to make steel 3-hour fire resistance for a multi-story steel building? I don't know, we need 3-hour fire rating? I
2
don't
hours
think.
is the statutory norms,
We have.
but you have
So what
intumescent,
is the,
you have intumescent, you have vermiculite, but now I think Tata has come out with some fireproof, fire-resistant steel,
It's available now.
so it's now available.
And I had find some of the people very innovatively done in one of the MLCP. They have used the first three-fourths of a column in a concrete encasing and the top in an intermission. So your joints are all done, so economical way of it. I hope the question is answered. Now, look, I was talking this question, the speed of a construction, innovation and all those things. One question is, where are we in terms of shop drawings? Because one thing which I find when we talk to developer or something, they got surprised why shop drawing. Because concrete drawing, concrete, straight, there is no in between. Still there is a drawing, shop drawing, then correction, then this is the process of it, and people got confused. Where are we in terms of development? Earlier I used to remember there was a separate shop drawing fellow, and he was more knowledgeable sometimes than the designer, because designer doesn't know. So where are we in terms of it? How you do it, Mohan, and how sir do it?
See, shop floor drawings, you're right actually when you compare to civil. Normally, that's one of the problem which we face. It's not only on the shop floor drawing when you compare, because I'm talking even they expect, a lot of our customers feel that civil, after they complete a work, I pay them. Whereas here you guys have only separate material and I have to pay you. Why? Whereas they do not understand 90% of the work is already done here, and that is a tax-paid material which is available at the site, and only the 10% work is done. So that is a similarity. Now in coming to the shop floor drawings, now we have earlier, it was all again a manual thing. Now we have got some new softwares coming up like Tekla and all. During design itself, you try to model it so that you can develop that into Tekla model, which can get into shop floor drawings. Shop floor drawings are basically it is required to meet your production requirements, which can be transportable material to the sites. So that is very important. So I think with the new technologies which has come up, the new softwares which have come up, I think shop floor drawings are much faster nowadays compared to what it was maybe earlier days.
Let me hear the other side of you also.
Okay. I think this question is very simple in the sense that if the engineer's drawing is drawn to detail that can be fabricated, then you really don't need the shop drawing. And that used to be the situation 50 years ago. I mean, I could issue a drawing to a fabricator and he could fabricate from my drawing without giving me any shop drawing. But today the situation has changed because the buildings themselves have become slightly more complicated. Now, if you had a profile cut, if you had tubular sections with profile cuts, the engineer is never going to be able to define that profile properly. It will be defined by TECLA, and the fabricator will have to produce a shop drawing in order to understand that and produce it. So this little bit of complexity changes the picture. Now, also the current industry, in terms of actually the more complex projects especially, is that the engineer will give the basic design that gives you the size of sections that you have to use and the geometry of the setting out and the general arrangement of it. And then the contractor, the subcontractor who does the steel, he then goes on to do the connection design, because the general intention here is that he may have a preferred connection, and so it's left to him to make that decision. And when he does that, he has to produce the single part drawings that a fabrication shop can actually produce very easily. I mean, that means they have almost every piece of steel is defined. And you just, and software like TECLA frankly makes this process quite seamless.
I have other problem. I had got a structural steel drawing for 100 ton, and when it come from the shop drawing and all, it become 120 ton. So 20% straight increase.
That's a connection, you know.
Connection,
Unfortunately,
that's
that's a connection, nothing more.
Look, please understand, layman, a developer, how he will know? Correct.
No.
Now, Amit, what is your confidence? You design, and then the shop drawing person has designed and given you connection.
No,
Where is the?
I'll tell you. I'm comparing both concrete as well as on steel. In concrete structure, you said drawings made and I'm done. That's it, only one set of drawing. Are you making bar bending schedules? If yes, it is same as shop floor drawings in steel. It is same. If you want exact quantities and you want to do it that way, you have to make detailed drawings. You cannot get away with it. Only thing is you have many draftsmen available who will do it on AutoCAD, or who will be able to calculate that easily. That's it. In shop floor drawings, you need little more skilled people to prepare those detailed structural steel fabrication drawing. Otherwise, process remains in both. There is no change at all. If you want good detailing, if you want accurate estimation, you have to do it.
I'll take one or two audience question, and then we'll come to final question before somebody starts showing me time. No, let's finish. Let the people on the dais speak. Otherwise, it will become difficult. We'll give you opportunity. Question is, do you think there will be preference given to steel building as we are growing shortage of civil and concrete executing labors, where the steel building less infrastructure when combined with the right machinery? Answer is yes. I did one building and we changed to part steel building in Orbit, Hyderabad, because we didn't have enough carpenter to reduce the beams, columns, and slab. Many times this was done, but today it's a win-win, or the question is based on what you can manage, what you cannot. You want to answer this?
Absolutely. In fact, the shortage of manpower is not only in civil, it is there all over. Because the people who are working or at the sites have come down drastically. And if at all you take in our country, there are only around 4 states from where people are coming. That's a fact. All said and done, you go to any site, they are either from Bihar, Jharkhand, some little skilled from Rajasthan, Orissa. These are the only places. You don't get anyone from any other state. Go to South India, don't really get some people. You go to wherever the governments are giving good subsidies, you don't get people. If at all they are, in fact, it's really a fact. And if the governments are, little not really taking care of the people, they are the only people who are available. So now, for a civil construction, the number of people required, you need a battalion of people working for longer time. Whereas at least in steel, it is lesser time, but that itself is a challenge. Today, one of the lacuna which I would say is that availability of manpower, skilled manpower, is one of the biggest challenge most of the projects or most of the industries or most of the steel manufacturers are facing through.
So basically there is a employment shortage and then the skill. So there is a big gap. Next question is interesting. I think all three of you can participate one by one. They say in the PEB structure there is a difference in designer's value and the vendor's design. If same PEB building is designed by the designer and same PEB building designed by the vendors. And I think this topic was discussed with Mohan last time also. So why this gap and how to reduce this gap? Means a building PEB which is done, so all can take one by one, and please let me know before we reach the final question.
Amit, want to start?
No. I'll prefer Mohan to start. Mohan, your answer has to be short. You can't give the long answer on that.
Basically, it is theoretical estimation versus actual, one. And second, of course, is basically on the connection designs, which actually changes the way we take it. And on the third point is, of course, on the experience and expertise of the designer.
So since you are saying since you are doing day in, day out, so you get more efficient system. Amit, do you agree, or what is your take?
Yeah, I do agree with what he said. There's no doubt about that. But there are various stages in the question that is asked. Stage number one, the first cut quotation from PEB vendor, it will be definitely higher than what you are expecting, what structural engineer is expecting. Because you have completely, the structural engineer has completely understood the project. They are yet to understand that. Till they get complete understanding of the project, they will quote you higher. You need to accept that. So how much accuracy is given to PEB vendor, or how much transparency is given to your quotations will depend on that. Stage one. Stage two, you are negotiating that they would like to earn profit out of it. They will say, my steel tonnage is 50 ton higher than what you have estimated, because that 50 ton is profit for them. So it will remain higher till that point of time. You have negotiated the contract, you have awarded the contract to PEB vendor. When the design comes, it will be 50 ton lesser than your design. Again, it's profit for them. So it's all, the reason is more or less non-technical, I will say. It's not technical. Now, how they are reducing, it's not that they are compromising on structural stability. They have more efficient designers who are doing steel design day in, day out. They have that, they are using them. There are many structural consultants also who can reduce it to that level. They also know how to reduce that. So if you ask me personally, if you know me, I don't know who has asked the question, if the person knows me, he knows that I will design that building, I will estimate it, and I'll give it to them. Let them do any number of iterations. End of it, you will have to come to this number. I know this number is true. But you have to have sufficient exposure. You have to have sufficient knowledge to arrive at those
repetitions
numbers.
of doing the same
Yes.
thing. Sir, your take on that.
My own, I'm not a PEB guy, okay, we do fairly, every time it's a unique structure. But my own understanding of the subject is that pre-engineered buildings mean that you have a definite process. And you have been doing that on several buildings. So anything that you have done many times, you will become a master of that trade. Whereas a consultant may be only doing it once or twice.
Very well said. That's
so
very
that
well
is
said.
essentially what I think.
Now, one question to you, last question before we go open for audience question. What is the lacuna, what you think, what in your opinion the biggest lacuna in the steel, and what is the way to improve in terms of Indian context? Internationally we'll have a lot more, but Indian context, what is the biggest lacuna and how to do it? All three of you, one by one, you take. Let's start with Amit and then
See, what he pointed out few minutes back, major challenge which all of us are facing is availability of skilled manpower. Right from design to construction to site erections to quality control, you name it, and we do not have sufficient number of qualified or skilled people available to do that job in steel. I think that's a major challenge we are facing. Maybe a few years down the line, we'll come over that. But today, yes, we are facing that.
I have a different take, sir.
Okay, I mean, what I can think is that you need good industrial training facilities for workers. And there must be a grading system where a worker will graduate as a welder or a fitter or a rigger. I mean, this is a very necessary requirement because I'm listening now, everybody is saying that there is a shortage of manpower in a country which is the most population in the world. Okay, so this is not easy to reconcile. So there must be a concerted effort on the part of the government mostly to set up industrial training facilities, and where people who come out from those facilities can command a better salary, where they can live a life. Now, if you look at a country like America, now they've grown much earlier, but even 30, 40 years ago, if you go to an American site in the suburban areas, you will find that most of the workers come driving to work, you know. Whereas here, maybe most of the workers, they probably are not, not sure how they are going to come to work or where they are staying. So you really need that development. And the next thing is, it's a good thing to develop a grading system for contractors. That means if you have projects of a certain magnitude, a contractor should have qualified persons of a certain level. He should have certain infrastructure facilities. I mean, that is one way of ensuring that somebody who has never done something suddenly gets to do something just because his price is low.
Yes, definitely. There are three things which I'd like to point out. One, of course, as I told, availability of people. Second important aspect is that people are not really interested in getting skilled. They do not want to really get skilled. And they would not like to get into, at least work in the sites, the hard-working job type of things, where they have other potential, which are potential jobs where there is no much work. And with this limited resource, the biggest challenge which we are seeing in the last, maybe I would say drastic changes in the last few years, India is growing at a phenomenal pace. There is a huge infrastructure coming in. Now, most of the infrastructure which is coming by the government generated or many are coming in the cities. So the people prefer to be staying in the cities who are working. Anyone want to go and work in the sites, the wants or wishes have gone up so high, which was not there earlier, to now, and that is visible. Today, if you really see, if you give a job, if you get some same worker who wants to work, if at all he is working in Mumbai or Pune or some big cities, okay. If you say that you go and work in a site, normally we work in industrial areas which are very far flung from the state. Very difficult for him. Again, there are a lot of wishes that there should be a vehicle for him to go and a lot of things. So
lot of human angle.
Humaning, that is one of the important aspect which is really playing a major role. And another which we are really seeing is that people who are, they would like to be a part of a group. And, they would like to now, because there is a money which is normally coming, normally people go out for only working. So they go out for a group and go out as a group. And what they will try to do is that if there are around 10 people, if 3 are skilled, they would like to divide and make into another 5-6 groups. So what's happening is that the skill set start coming down. And these people have their own preferences to go. So this is one of the thing. And another aspect, one of the lacuna which I see compared to, organized to unorganized, the level of education of people, like engineers. If at all you have an engineer who is qualified, has a different thing, and who is not really qualified, there is a lot of difference. The way he visualizes things. When I see the work involved may be similar, but the project management skills, the way they could react to the problems, resolve the problems, or go with a very process-oriented way of solving will be completely different. This is some of the lacunas which I could see.
So there are two more points I want to add. One is the acceptability of poor standards. So until we start improving on a minimum acceptability level, things will not improve. We are accepting. As a society, we are accepting the many. And third is, if you go to building segment, a normal person is confused on a steel. Concrete is simple for him. Look, soccer is most famous game in the world because it's a simple. Football is a simple, you don't have to think too much of it. Steel is complicated. I'm giving you the third person. Now, I'll have a time for a 2 or 3 question. Your question should be good enough to take it. No, sir. Suggestions and this thing.
You all talked about the engineering aspects, but the real problem is that steel penetration is majorly into industrial projects and the architectural fraternity is out of it. And they are not able to comprehend the nuances of steel. So you need to start the knowledge series from steel vendors, from steel engineers also, and the architecture.
This is the knowledge series only, but the point is, look, no, it's not like that. If you have to sell your car, you have to make it popular to people to purchase it. It's a very simple in the world. We can't say, ki, I am making best product, he's not purchasing. It doesn't work. And
I agree with you.
somehow I disagree with that, but I have one statistics to talk. India is a $3 billion economy. 10% or 9% is roughly the civil construction, which bring it to 200 to 300 billion dollar. If you convert steel, overall work is $200 million. So that says your percentage. I'm just giving some numbers may not be correct. Anybody, any other question before we conclude? I seen the next panelist already coming in. So if anybody has any question, any suggestion, any point to make, please. I think we have exhausted the point of it. So it was a good discussion on steel. End of the day, it's not a steel versus others. It's a combination. I was listening to Professor, our C.N. Narayan sir, honorable this thing. We are a small boys picking the pebbles in the shore of the vast knowledge of steel. So this is just a beginning for us. When we did couple of difficult building, we have realized that we have to go and refer lot of things in UK or US for some of the most complicated matter. So still we are at infant stage, and it's a big achievement from yesterday, no steel, to today we are in this scenario. I thanks the panelists for knowledge. Apologies if I provoke them to the something little more. But thank you very much. You are a wonderful audience, very attentive and very supportive. So my sincere thanks.